Sorry? No. We're going to be doing more than that. Hopefully at least one more after this, maybe two. Let's talk about momentum. What is momentum? Well, if you want me to give you a non-physics definition, it's the amount of motion an object has. The amount of owie that it would do if it hit you. Which again is not a physics definition, but if you're asking me, how do I think about momentum? How much it would hurt if it hit me, if it ran into me. So example 1 says this: for each of the diagrams below, state whether the amount of motion is comparatively large or small. So the first situation, I'm going to zoom in a little bit so you can see it in the back. If we have a tiny mass and a tiny speed, let's think ping pong ball. Would it hurt to get hit by a ping pong ball? No. So do you think it has a large amount of motion or a small amount of motion, Mika? What if you have a small mass moving really fast? What would be an example of a small mass moving really fast? Can you think of a real life example? Let's even go faster. Even faster. Here's what I'm thinking. Would it hurt to get hit by a bullet? This is a larger amount of motion. So I think motion is going to depend on at least how fast something is going. The amount of motion is going to depend on how fast it's going. Is that okay, Ella? Makes sense? What about, instead of a ping pong ball, what about a bowling ball? Traveling really slow. Would it hurt even if the bowling ball was traveling really slow to get hit by it? Yes. So that also has a pretty large amount of motion. Can anybody tell me two things that they think the amount of motion depends on? I'll give you a hint. One is velocity. Can you guess what the other thing is? Zaina?
Yeah.
Mass. So the worst would be if an object has a big amount of motion and a big amount of mass. What's something that's really heavy and goes really fast that you would absolutely not want to get hit by? Oh, how about a locomotive train? In fact, you may have seen in the movies when a train runs into a car, because that's a classic movie trope, the car gets stuck on the tracks. You may notice the train hardly loses any motion at all. It just keeps going. It slows down a little bit because there is a force applied, F equals ma, but it's got such a big mass, its acceleration is pretty minuscule. So a locomotive or an artillery shell, something the mass of the bowling ball, traveling the speed of a bullet, would not want to be hit by that. You know what? Cross out large, cross out small. Really, really large. We need one more category, I think. It says explain your answer, but I think it's kind of intuitive. So the amount of motion, we're going to give this a name. We call it momentum. Momentum. So momentum depends on both mass and velocity. What would be a good letter to use for momentum? Well, lowercase m, but that's taken by what? Mass. What about an uppercase m? That's taken by something else. So because momentum equals mass times velocity, because it's a product, you're multiplying, we use a lowercase p. It's the motion product, is what it used to be called. Have I mentioned we don't have enough letters to go around? Because we don't. Yeah. Is it on your formula sheet somewhere? I think it should be just underneath the forces section, I think. Underneath F equals ma, I think it should say P equals M. Okay. Okay. Momentum is a vector quantity, which means we're going to have to pay attention to direction. So what I should have done is I should have put a vector sign above the letter P as well. In fact, you're going to notice in this unit, I'm going to start paying way more attention again to direction. Makes a difference. We're not going to go crazy. We're going to keep it still fairly straightforward with letting one way be positive and one way be negative. But we are going to have to let one way be positive and one way be negative. What are the units for momentum? Well, what are the units for mass? Kilograms. What are the units for velocity? So the units for momentum are kilogram meters per second. Acacia's looking at that and going, haven't they shortened that, Mr. Dewick? Because remember, a Newton, come on, computer. A Newton, that's a terrible color to see. A Newton was a kilogram meter per second squared because it was mass times acceleration, but we decided to call that a Newton. Why haven't they done that for kilogram meters per second? It's in progress. There is a committee, they're talking about renaming that an Einstein, because Einstein doesn't have a unit named after him. But it's been about 15 years and it's a bureaucracy, it's a committee. So maybe in your lifetime, the official unit for momentum will be called the Einstein. But right now, we're writing out kilogram meters per second like peasants. Ugh. There's another way to write kilogram meters per second. I wrote here, note that a Newton second can also be used. Say what? Here is a Newton second. What do we measure in newtons? Starts with letter F. Force, F equals what? So this is actually the same as a kilogram meter per second squared times seconds. And you notice this S cancels out this S, and I end up with, Acacia, kilogram meters per second. So if you want to, you can write momentum as Newton seconds, which is a tiny bit shorter than kilogram meters per second. I don't care, but they haven't come up with a shorter version of them yet. So how do I measure momentum? I usually just remember, because it's mass times velocity, kilogram meters per second, because mass is kilograms and velocity is meters per second. I've memorized those. Anytime I'm giving you a brand new concept, I like to try and give you an idea of what's really big and what's really small. So let's look at some momentums. Plural of momentum is momenta. So let's look at some momentum. It says, estimate the magnitude of the momentum of a top pitcher's fastball, and then estimate the magnitude of the momentum of a person and bicycle on a relaxed ride, and then estimate the momentum of a car driving on a city street. Okay. What's the mass of a baseball? Not a softball, hardball, a baseball. What do you think? Is it 1 kilogram? This is 1 kilogram. Is that how much a baseball weighs? More or less? Okay. Is it half a kilogram? This is half a kilogram. Actually, baseballs aren't very heavy, are they? Let's go, I don't know. What do you think? 0.2 kilograms? Now, if you were clever, you might have looked at the next question further down the page, and you might have said, oh, what is the mass of a baseball? think it says, doesn't it? So 0.14, I'm going to use 0.15. I'm going to use a slightly rounder number. 0.15 kilograms. All right. It says a top pitcher. So in the major leagues, how fast can the best pitchers pitch? It's going to be in miles per hour because that's the units that they advertise. What do they hit? The top ones. Those of you that are baseball fans. Sorry? 100. Yep, I agree. 100 miles per hour. Cole, do we do physics with 100 miles per hour? Do we do physics with miles per hour? No? Well, you know what? I'm going to cheat. Convert 100 miles per hour to meters per second. I got 44.7. I'm going to round up. We're doing some really rough numbers. I'm going to call it around 50 meters per second. Remember, momentum is mass times velocity. On your calculator, can you go 0.15 times 50? What do we get? Cohen, what'd you get? $7.5? Anybody else? Yep. Units, Cohen. Okay. If you got hit by a baseball, would it kill you? Probably not. Would it send you to the hospital? Depending on where it hits you, probably not. If it hits you on the torso, you're probably going to be okay. Would it hurt? So 7.5 kilogram meters per second. This I consider ouch. If it hits you on the elbow, you'd be saying some swear words and you'd be rubbing your elbow, but they're not calling an ambulance. Now, if it hits you on the side of the head, that's different, but we're talking just in general. Right around 10 kilogram meters per second. Owie, 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 but not, call emergency, call 911. Bike and rider. What do you think the mass of a cyclist and the bike might be in kilograms? Well, let's make it an adult. What's the mass of an average adult in kilograms? What's the mass of an average adult in pounds? 10? Yeah. No. 500? What's the mass of an average adult in pounds? 160? Okay. And let's add a bike. What do you think a bike weighs in pounds? You know what? Since we're doing some rough guesses, let's go 160 pounds. Let's make it a 40-pound bike. Let's make it 200 pounds grand total. Convert 200 pounds to kilograms. I'm getting 91. What's a nice round number to use close to 91? How about 100, boys and girls? $90 is a nice round number. Okay, speed. Read the question. Read part B. Is this person speed sprinting? Are they pedaling like crazy? No, relaxed ride. Okay. What's a relaxed ride in meters per second? Well, let's suppose that my room is roughly 10 meters long. Riding that in 1 second, would that be relaxed? Or would that be slow? Or would that be fast? In other words, 10 meters per second. So imagine someone going by once. That's ballpark-ish, I think. 10 meters per second. You're pedaling, but you're not speed pedaling, I don't think. So I'm going to say this one you probably don't need a calculator for. In your head, without a calculator, can you go 100 times 10? Ella, what'd you get? Keisha, put the calculator away. You don't need a calculator. 100 times 10. You just add it. Thank you. Units, Acacia? If you were walking on the street and a cyclist ran into you, would you die? Probably not. Could you break bones? You know what? This is, I consider, the injury level. If you have to absorb all that momentum at once, you're going to be okay, but you might break a bone. Okay? So around 10 kilogram meters per second, owie, owie. 1,000 kilogram meters per second, yeesh. C, car driving on a city street. Okay. What's the mass of a car in kilograms? Thousand? You know what? Let's make it 1,500. I think 1,000 might be a little light. Let's make it around 1,500 kilograms. This specifically says on a city street. What's the speed limit on city streets in kilometers per hour? 50 years. I think 50 in a subdivision, right? There's signs, but usually 50. Convert that to meters per second, please. Something to do with a 3.6. I can't remember what. What'd you get? Sorry? 13.8? Let's call it 15. Again, going for kind of a nice round. Oh, 1,500, Mr. Duick. 15-ish. Okay. How much momentum? You can use a calculator for this one if you really feel you need to. Is it 22,500? Or you can do it in your head like I just did. If you get hit with 22,500 kilogram meters per second of momentum, hospital or death? Probably fatal. Okay. Although it depends also on how fast you absorb the momentum. Do you absorb it instantaneously, or can we spread it out over a while? If we can spread it out over a while, not so bad. Example 2, a baseball of mass 0.14 kilograms is moving at 35 meters per second. Okay, Aiden, what does A want me to find? Magnitude just means size. So here's what you... Okay, how do I find momentum? That's the units. What's the equation for momentum? What's our symbol for momentum? Okay, lowercase p with a vector sign, and it's equal to mass times velocity. Aiden, what's the mass? What's the velocity? What do you get? I can do this in my head. Is it 4.9? 0.49? No. Let's see. There's going to be a 2 I can pull out with that 5. So that's going to give me a 10. And then it's going to be 7 times 0.7. 7 times 0.4. 4.9? 4.9. Kilogram meters per second. Fahim, what does B want me to do? Well, let's see. Let's read it together. It says, find the velocity, magnitude of the... Why am I saying magnitude of the velocity? Momentum is a vector, and I didn't give any directions. So all we can find right now is how big, but not which way. Find the magnitude of the velocity at which a bowling ball would have the same momentum as the baseball. In other words, how hard would I throw a bowling ball at Cohen's face if I wanted it to have the same amount of momentum as this baseball? Fahim, what's this asking me to find? I agree. Is there any hint that this is a v initial or a v final? Do you see another velocity in this question anywhere? Okay. Do you see a time or an acceleration or a displacement in this question anywhere? Oh. Is there a velocity in any other equation that we've recently learned? What? Now, is there a velocity in any recent equation? I'm looking for the actual equation. Something equals something, something. I'm going to solve this with momentum. Get the v by itself, please. Here's another way to find velocity. I'm not going to memorize it. I can derive it. What momentum? 4.9. What mass? 7.26 kilograms. How fast would I need to throw a bowling ball if I wanted it to have the same momentum as a baseball? Slower, definitely, because it has more mass. Fahim, what'd you get? 1.48. Sorry? 1.48 or 1.49? Rounded off properly? I don't think it can be bigger than 1. I think it's going to be way smaller than 1 because I got a bigger number on the bottom.
0.675.
So that's a 3. Is it 0.675? Is that rounded off properly? Okay. Momentum is what times what? It's mass times velocity. Turn the page. Example 3. A 12-kilogram rock is dropped. I would probably mentally underline the word dropped from a high cliff. What's its momentum upon impact, magnitude, and direction? Ooh. Okay. Okay. Ella, right hand Ella. Ella M. What's this want me to find? Okay. Well, I know that momentum is mass times velocity. Ella, do I know the mass? Do I know the velocity? So even though this question says find the momentum, you know what I'm going to spend most of my time finding, I think? Velocity. I'm going to do a little line over here and I'm going to say, okay. Suggestions. Any suggestions, folks? Cole. Okay. So, how's that help? I agree. I think I'm going to solve this next section using kinematics, I think. Because I think I've done cliffs before. What did you say? Oh, dropped. VI is 0? Oh, you know what that means, Ella? That's VF, and I guess it's going to be VF over here. Okay. Ella, what else do I know? Sorry? Displacement? What's the displacement? Is it 75? Okay. What else do I know? Oh, this is free fall. There was something else I always knew in free fall. What's 9.8? But I think back in that unit we always called it negative, right? Can you, which equation has a VF, a VI, a D, and an A in it? How would I get the VF by itself? Square root. And in fact, since VI is 0, I guess I could have just chucked that. I'm going to get VF equals the square root of 2 times negative 9.8 times negative 75. I get 2 times negative 9.8 times negative 75, 1,470. That seems high. Oh, square root. I get 38.340. Is that right? No, it's wrong. Why must it be wrong? Which way are we traveling when we hit the ground? Down. We'll call it negative. And I'm going to walk this over to here, and now I'm good to go. Ella, momentum is mass. Oh, what was the mass, Ella? Times velocity, negative 38.3. I'm going to use my answer button. And I get 460. Oh, wait a minute. Negative 460. Is that right? It said Ella, what did it say in brackets? Magnitude and what? I would live with negative 460 kilogram meters per second, or 460 kilogram meters per second. What direction does that negative tell me? Down. Where I would be fussy, don't say negative and down, because to me, negative down is technically up. So use one or the other, but not both. So there's a little free fall review. That was good. And we're done. Momentum is mass times velocity. What's your homework? Your real homework is to work on the study guide and get ready for the test. But wait a minute. What's on Wednesday? Do Thursday. 1 is good. 2 is good. 3 is good. 4 is good. 5 is good. 6 and 7. Gonna skip 8. 9 is good. 10 is good. Skip 11. 12 is good. 13, skip 14. A lot of those are straight plug and chug. A few aren't, but most of them are kind of straight plug and chug. Momentum is mass times velocity. Its symbol is the letter P. It's a vector. Mr. Derek, you have any cool videos or thought puzzle? I got a new unit. Give me time, but I got to introduce some concepts to you before I can explain some stuff.